Hi there, Daniel here from the Drasi team. Today I want to walk you through a demo that joins data from a Postgres table to live resource statuses of Kubernetes pods. In this example, we will have a table that contains a list of high-risk container image tags, and we'll use a continuous query to join this data to the containers running in our Kubernetes cluster. We have Drasi running in my environment, as well as an instance of Postgres, with a table to contain the list of these high-risk container images. Let me show you. Here you can see we have a table named risky image that contains two high-risk images and a reason for the risk. Notice my app 1. Over here we have a Kubernetes manifest to deploy two pods, my app 1 and my app 2. My app 1 will deploy version 0.1 of my app, and my app 2 will deploy version 0.2. Let's run this quickly. Let's create a source for this Postgres database and a source for our Kubernetes cluster. But before we can do that, we need to get the credentials of the Kubernetes cluster. I'm running K3D, and this command will extract the credentials from our current kube context and store them in a Kubernetes secret, which we'll then reference from the source. I'll show you in a minute. Let's just grab these credentials and store them in a Kubernetes secret. There we go. Let's have a look at our sources here. First one is a Postgres source that looks at the risky image container, and we'll call that one DevOps. The second one is the Kubernetes source, and you can see it gets the kube config from the secret that we have just created. Let's go ahead and apply these. And let's make sure that they are ready and to go. So the Kubernetes source will create a pod node in the queryable graph that will look exactly like what comes out of the Kubernetes API, which looks something like this. Now, as you can see, what we're interested in is the array of containers in the container statuses field, which is inside the status field. And what we want to do is unwind these containers so that each container in this array is a top-level node within the graph. And in order to do that, we will use the unwind middleware. Let's have a look at this query. So you can see here we are subscribing to the Kubernetes source, and we're grabbing the pod node. We're also subscribing to the DevOps source and grabbing the risky image table. And we're applying the extract containers middleware to the Kubernetes source. Let's have a look at this middleware here. We're using the unwind middleware, where it's grabbing all the incoming pods, and it's using this JSON path expression to find the array within that payload that it's going to unwind. And for each entry in that array, it's going to create a new graph node with the label container, and it's going to use this JSON path field as a unique key for that container within the scope of that specific pod. And it's also going to create a relation node with the label of owns that's going to connect the pod to the container. Now that we have a top-level container in our queryable graph, we can create a synthetic join between the risky image table and this new pod on the image field from the Postgres table and the image property that's coming from that nested container object. Then in the cipher, it becomes really intuitive. We just have the pod, which owns the container, and that data is flowing from our Kubernetes. And then we have the synthetic has image join, and then we have the risky image, which is flowing from the Postgres table. So let's go ahead and run this query. I'll use the debug option from the VS Code extension for Drasi. And as you can see, we have one entry in here, which is for my app01, which is what we're expecting. Now what we're going to do is we're going to create a new entry in that risky image table, and it will look like this. We will add an entry for my app02, and the reason will be a critical bug. So I'm just going to grab that SQL there, And let's log into our database and execute that SQL. Before I execute that, I'm going to jump back to our live query results here, and there we go. Now we have a second entry in our dashboard. The next thing we're going to do is actually upgrade my app 02 to my app 03, which will actually cause it to be removed from the dashboard. So we have a script here to do that. I'm going to grab that script, and before we run it, let's jump back to our live query results. And this will probably take about 10 seconds or so, because Kubernetes has to tear down the old pod and bring up the new one. But once the new one is up, then we will see this entry disappear. And there you have it.